Alright, so I'm just going to try recording this with the mic on. Stick it right there. I've got a bit of noise locally, so hopefully it's not too bad. You've got the air conditioning on, it's a bit muggy today. So this is my Arduino screen. I was actually going to try and do actual live capture straight off the computer, but unfortunately the I can't actually capture audio on the computer, so I'm still do it through the phone and put it in front, unfortunately. So anyway, that's one of those things. I can't do much about that right now. I've ordered a USB microphone, but it'll take a while to get here, so we'll see how we go. Anyway, so this is for the extractor fan for the bus, which I showed you in a video a couple of videos ago. So this is the code for it, so I'm hoping I can actually get this to capture. It's like it's zooming in and out. What's it pulsing? Zoom. No, hold on, this is being a pain. Come on, it's not liking focusing on the screen. Right, hopefully that'll do it. So so it's the code here. Obviously got the initial setup stuff. It's got all my comments in it still, typos and all, corrections and all. It's all in here still. This is the actual native file. So I hope you can actually have a look through this and see what I've done. So defining temperature numbers and floats, defining pins, that kind of thing. Software serial, because I'm using the serial display, obviously. Initiating the LCD protocols, some things in here which I can actually turn features that have displayed on and off. I just call those as required. Obviously the setup loop here. I'm using an external analog reference in order to trim the actual value. This is all the LCD stuff here, so it's initiating it, putting a little splash screen up with some delays and things like that. Well, those delays are actually a bit long, so I think next time I work on it I'll shorten them a little bit and make it a bit faster. This is the smoothing to help smooth out the actual readings it's getting from the sensor. I wrote this a year ago, so I don't actually remember it very well, so hopefully you can actually see it okay. And make sense of it, because I don't remember what I did, to be honest. So it gets the temperature off the sensor, reads it, does a comparison with the reference voltage to work out what its value is, and does some maths on that to work out the actual degrees. You can see I've got two versions here whilst doing basic stuff. So this is with the correction, I think. So 10 millivolts per degree with 500 millivolts offset in degrees. So anyway, and I got that 0.004 to calibrate sensor, because I realised it was that far out. There's an offset anyway. Then you got the main loop there, which does all the looping and does all the displays what's going on. So it's got the averaging there, both the trim value and the sensor averages both to help smooth it all out to make the comparisons a bit better. That does the actual comparisons here and decides what to do, and displays the temperatures, and this is all the serial outputs when I'm doing testing here, so you can ignore that. So here you can see I've got my tolerances here, so I've got plus 0.1 degrees, so there's 0.1 degrees above the set temp that will turn on, and if the backlight is turned off it will turn it on, just so you can see what's going on. So the backlight's normally off if the fan isn't running, and also if it goes like 1 degree below the set temperature, then it turns the fan back off again to allow for that, so it's not trying to trip on and off on and off on and off at the same time at the same temperature setting. And I also got the actual LCD outputs here, and then if it notices that the fan is on, it'll put that little indicator on. So I mean, it's probably overly complex for what it's doing. I've probably got really bad code. It wouldn't surprise me. I'm not good at optimizing code. I just write what works, sometimes by trial and error. So there's probably, I'd say, a lot of stuff here is only used when it's called, when I'm doing the initial setup, but it's not used again. So LCD clear is used, backlight on off is used, splash screen thing and baud rates are only set on initial configuration, so those aren't really called. Obviously set position is used every time you want to print something to the LCD. But yeah, it's quite an interesting little thing. It took me a while to get the thing to actually work nicely, but I mean, I'm sure there's a better way of coding this and writing this out and making it nice. I hope you can actually read this well enough. Also, I'm using millis for timing and comparisons, so it knows when something's updated. So it does. It remembers the last reading and does a comparison on that and stuff like that. So anyway, so it's got a timeout here for the millis. So current millis plus timeout. So that way it will turn the display for this period of time as well. Here we go. Here it is. Here, current millis, greater than timeout millis, and last state is off. So I don't remember this very well, but anyway, so it was a year ago and I wrote it and looked at it since. So hopefully someone can, maybe use a bit of this code here. If there's enough interest in it, or I could actually just copy and paste this into a text file and chuck up on my DevPom site and have you download it if you want it. I'm not really too worried about anyone copying it because it's probably not that good anyway, to be honest. But there it is. So hopefully you can, maybe use some of this if you want it yourself to see what I've done. But so I'm quite willing to put a copy up in text, the actual text file of this as it is, if someone wants to try and replicate it. So I just wanted to show you it, so done.